In this video, we want to talk about Z's in reverse, which is basically when we're given a percentile. We're saying the top 20% this or the bottom 10% this. And for those questions, of course, there is the long way to do it, but then there's also the shortcut way. So I'm going to show you both, and we're going to focus more on the shortcut way because it just makes sense to cheat in this case. So looking at this question, we're looking at, again, the same SAT data, which was the 500, 100. And it says, suppose a college only admits students who score in the top 10% of SAT scores. How high of a score must a student get to be eligible? So what I have here on the slide is the cheat way, but let's go ahead and pop over. So here I'm going to look at the cheat way, which is 500, 100. And we're saying that the question says the top 10% and how high of a score must a student get to be eligible. So you can kind of choose two ways. The way that I showed it here was that I know if I'm in the top 10%, then 90% are below. So here I can put 0.9, and I want you to notice that what I did here is I entered the value in for the probability and letting it compute this value, whereas in our last examples it was the opposite way. But if I click compute, notice it gives me the 628.15516, which is the correct answer. Now, I can also flip this around and make this 0.1, which means there's 10% greater than me. So 90% to the left, 10% to the right, but notice it gives the exact same answer. Now again, this is the cheat way. So if you ever have to do a question where you're showing all of your work, we would just go back to the 0 and the 1, and here I would still put 0.1 to the right, so it's the same picture, and notice what it gave me is 1.282, we'll say. So over here, I'm going to use 1.282 as my z-score, and in this case, I'm finding the observed. So this is going to be observed of x minus standard deviation of the mean of 500 divided by the standard deviation of 100. I'm going to multiply to get 128.2 equals x minus 500. I'm going to add 500 to each side, which gives me 628.2 equals x. So notice I can do it the exact same way using a z-score in reverse, 1.282, and then working out the z-score formula, solving for a new observed value. Easy peasy. So here are 3 questions. I am totally fine with you doing all 3 of these questions using the cheat method. That is what I will do when I go through them with you. So press pause right now, try these 3 questions, and then press play to check your work. So first question, a normal model. We're using the 24/6 again, so let's pop over here and just change that. Again, I'm using the cheat method on all of these, so 24/6. And this one says the top 20% of cars, which means that there would be 0.2 to the right or 0.8 to the left. I'm going to do it this way, 0.2 to the right, which means the fuel efficiency would be cars that get 29.05 miles per gallon or greater. So for the second one, I lied a little bit because we can't really do this one the cheat way. On this one, because it's asking me to find the mean, and the second one is asking me to find a standard deviation, that means I can't use the cheat way and I have to do it the long way. So let's look at that together. I'm still going to use the same method, finding the top 20%. So back over here, I'm looking at, instead of 24, 0, and instead of 6, 1. And I want this to be 20% to the right. And instead of giving me that miles per gallon value, it's giving me the z-score value. So I'm going to use 0.8416. I tend to go to 4 places when I do that. And my observed value is going to be 32 because it wants the top 20 to be 32 miles per gallon, minus my expected value, which is my mean, but I'm solving for mean, so that's my unknown, My standard deviation is 6. So now of course I have to do the math. So I'll multiply each side by 6. That gives me 5.0496 equals 32 minus x. Subtract 32 from each side gives me negative 26.9504 equals negative x. Of course, that doesn't make any sense. Positive 26.95 equals x. And so that would have to be our new mean. We're going to do the same thing for standard deviation. So it's still 0.8416. We're going to do our observed value of 32, and our expected value will stay at 24. And our standard deviation is now our unknown because we're changing the standard deviation. So now I'm going to do some cross multiplication, and that gives me 0.8416x equals, and then of course 32 minus 24 is 8. So then I'm just going to take each side divided by 0.8416, and that gives me 506. Now in this case, the standard deviation got worse, so that wouldn't really make any sense, but in order to keep with what they're asking us to do, that would be our new standard deviation, is 9.506 miles per gallon.